Anticipated 50% increase in exoplanet research funding across 4 sectors: astronomy, astrobiology, space exploration, and education by 2027. Overview. The anticipated 50% increase in funding for exoplanet research by 2027 marks a significant moment in the fields of astronomy, astrobiology, space exploration, and education. This funding boost is expected to reshape scientific priorities, enhance public engagement, and deepen our understanding of exoplanets and the potential for extraterrestrial life. Funding landscape. Current state of exoplanet research. Exoplanet research currently accounts for approximately 3 to 4% of refereed astronomy articles, with 15 to 20% of space missions focused on this area. Organizations like the Canadian Space Agency (CSA) are crucial in this landscape, outlining funding opportunities that align with their objectives, including planetary exploration and space astronomy. Noteworthy projects such as the Pandora Mission aim to characterize exoplanet atmospheres, while the Nancy Grace Roman Telescope is expected to discover around 100,000 new transiting exoplanets. Use cases and data integration. The integration of data from various sources is becoming increasingly crucial in exoplanet research. Current projects are leveraging advanced technologies and methodologies, including those provided by citizen science initiatives. The CSA has recognized the importance of these advancements and is committed to fostering collaboration between Canadian researchers and international space missions, enhancing Canada's role in global space exploration. Key points of impact. Public engagement and citizen science. A unifying theme across various reports is the growing emphasis on public engagement in scientific discovery. Citizen science initiatives have significantly increased participation in exoplanet research, fostering a culture of inclusivity and collaboration. These initiatives not only promote STEM education but also enhance public interest in the search for extraterrestrial life. Positive public perception. The media's portrayal of exoplanet research has positively influenced public perception. As the search for other Earths gains traction, public support for funding and the development of research infrastructure has grown. This shift in perception is crucial for sustaining long-term investments in exoplanet research. Differences in perspectives. While some sources focus on the societal impact of exoplanet research, emphasizing public perception and citizen science, others highlight the practical aspects of funding opportunities and eligibility criteria. This dichotomy illustrates the multifaceted nature of exoplanet research, where both public engagement and administrative frameworks are critical for success. Timeline of key events. 2022, the CSA announces funding opportunities for the 2022 to 2027 period, focusing on advancing space science and technology. 2023, the CSA conducts its second application cycle with project submissions and anticipated funding allocations. 2024, a significant funding increase is expected, with public engagement initiatives continuing to grow. Notable projects like the Pandora Mission and the Euclid satellite begin to take shape. 2025 to 2027, ongoing projects are anticipated to yield results, with a final application cycle planned for 2026, potentially leading to new discoveries in exoplanet research and astrobiology. Section-specific impacts. Astronomy. The increase in funding is set to enhance research capabilities in astronomy, particularly in detecting and characterizing exoplanets. The anticipated funding will support advanced telescopes and instruments, paving the way for groundbreaking discoveries. Astrobiology. The implications for astrobiology are profound, as increased funding allows researchers to explore the potential for life beyond Earth. Studies focusing on the atmospheric composition of exoplanets and their habitability will gain momentum. Space exploration. Funding directed towards space exploration will enable more ambitious missions to exoplanets, including sample return missions and atmospheric studies. This will also facilitate international collaboration, furthering scientific understanding. Education. Education initiatives will benefit from increased funding promoting STEM engagement among students and the public. Citizen science projects will provide hands-on learning opportunities, fostering a new generation of scientists. Conclusion. The projected 50% increase in funding for exoplanet research by 2027 signifies a pivotal moment for scientific exploration and public engagement. This investment has promising implications for our understanding of the universe and the development of future technologies. The integration of citizen science with academic research highlights a collaborative effort to expand our knowledge of exoplanets and the potential for extraterrestrial life. As funding cycles progress, the scientific community anticipates groundbreaking discoveries that could reshape our understanding of the cosmos. The anticipated 50% increase in funding for exoplanet research across the four sectors of astronomy, astrobiology, space exploration, and education by 2027 is a promising development that highlights several counterintuitive aspects of scientific funding and public perception. Here are some key counterintuitive insights derived from the content. 1. Public engagement drives funding. Traditionally, scientific funding decisions have been driven primarily by academic merit and the potential for groundbreaking discoveries. However, the increased emphasis on public engagement in exoplanet research indicates a shift towards prioritizing societal interest and involvement in scientific endeavors. This suggests that funding bodies may be increasingly influenced by the public's enthusiasm for exoplanet exploration and the potential for citizen science initiatives to contribute to meaningful scientific discoveries. 2. Citizen science as a research driver. The rise of citizen science platforms and the integration of amateur astronomers in exoplanet research may seem like a secondary or supplementary aspect of scientific inquiry. However, these initiatives are becoming central to the success of exoplanet research, demonstrating that non-professional contributions can significantly enhance data collection and discovery processes. This challenges the traditional notion that only professional scientists can contribute effectively to high-level research. 3. Shift in research priorities. The substantial increase in funding for exoplanet research represents a notable shift in research priorities, moving away from more traditional areas of astronomy and space science. This shift may seem counterintuitive given the long-standing focus on other astronomical phenomena such as black holes and cosmic background radiation. It suggests that funding agencies are redefining what constitutes cutting-edge research, with exoplanet studies taking center stage, possibly due to the growing belief in the potential for discovering extraterrestrial life. For interdisciplinary collaboration, the integration of funding across astronomy, astrobiology, space exploration, and education highlights an increasingly interdisciplinary approach to research. This collaboration between different fields may be surprising, as traditional funding models often compartmentalize scientific disciplines. The growing recognition that understanding exoplanets requires insights from multiple fields signals a broader shift towards collaborative research methodologies that could redefine how funding is allocated in the future. 5. Media influence on research perception. The role of media coverage in shaping public perception and support for research funding is another counterintuitive aspect. While one might assume that scientific merit alone guides funding decisions, the influence of media narratives surrounding exoplanet discoveries has fostered a more favorable public perception, which in turn drives funding. This indicates that effective communication and public engagement strategies are as crucial as scientific results in securing funding. 6. Technological investment versus human capital. The emphasis on technological investments in exoplanet research, such as the development of missions like the Nancy Grace Roman Telescope and the Pandora Mission, may suggest a future dominated by large-scale capital-intensive projects. However, the counterintuitive aspect lies in recognizing that the success of these technologies also relies heavily on the involvement of a diverse and trained workforce. The funding increase is not merely about technology but also about cultivating human capital in the form of skilled researchers and educators in the STEM fields. 7. Funding accessibility for diverse institutions. the structured funding opportunities provided by the Canadian Space Agency (CSA) are intended to include a wide range of institutions, including smaller universities and post-secondary institutions. This approach may be counterintuitive as it challenges the traditional reliance on prestigious institutions for groundbreaking research. By diversifying the pool of eligible institutions, the CSA is promoting a more equitable research environment that acknowledges contributions from across the academic landscape. 8. Evolving definitions of success. The criteria for evaluating research proposals have evolved to include metrics beyond traditional outputs like publications and citations. The inclusion of parameters related to public engagement, collaboration, and the development of highly qualified personnel indicates a broader definition of success in research funding. This reflects a counterintuitive shift towards valuing the societal impact of research alongside academic achievements. 9. Long-term vision versus immediate results. The multi-year funding cycles and the focus on long-term projects underscore a shift in scientific funding paradigms. While immediate results have often been prioritized in research funding, the increasing recognition of the long-term nature of space exploration and exoplanet research suggests a counterintuitive acceptance that groundbreaking discoveries may take time and require sustained investment. 10. Global collaboration. The intention to make Canadian researchers integral to international space missions highlights a counterintuitive aspect of national funding strategies. Rather than isolating national research goals, there is a growing trend to foster international collaboration, recognizing that exoplanet research benefits from a global perspective and shared resources. In summary, the anticipated increase in funding for exoplanet research reveals a multifaceted and counterintuitive landscape that challenges traditional notions of scientific inquiry, funding models, and public engagement. The evolving dynamics around funding suggest that the future of scientific research may be increasingly participatory, interdisciplinary, and aligned with societal interests and values. The anticipated 50% increase in exoplanet research funding by 2027 across the sectors of astronomy, astrobiology, space exploration, and education is a momentous development that can have far-reaching implications. While many aspects of this funding boost have been highlighted in various reports, certain critical insights and details may be overlooked by the general audience. Here are some of the significant elements that warrant attention. 1. Citizen science and public engagement. The rise of citizen science initiatives, as discussed in multiple sources, demonstrates the increasing involvement of the public in scientific exploration. Citizen science creates a bridge between professional researchers and the general public, allowing non-experts to contribute to meaningful scientific discoveries. This involvement not only enhances public understanding of science but also fosters a sense of ownership and investment in the research process. Significance: this engagement can lead to increased public support for scientific endeavors and funding as the public becomes more invested in the outcomes of research efforts. Additionally, it broadens participation in STEM fields, particularly among underrepresented groups, which is crucial for the future of science. 2. Impact on educational initiatives. The reports underscore the role of exoplanet research in driving STEM education and outreach. As interest in exoplanets grows, educational institutions can leverage this momentum to encourage more students to pursue careers in science and technology. Significance: by aligning educational programs with current scientific research, educational initiatives can foster a new generation of scientists who are well prepared to tackle future challenges. The funding increase can help implement new curricula, training programs, and educational resources that focus on exoplanet science. 3. Funding allocation and opportunities. The Canadian Space Agency (CSA) has outlined specific funding opportunities for various initiatives aligned with its strategic objectives. These include co-investigator roles in international missions, guest observation partnerships, and data analysis projects using CSA-supported instruments. The structured approach to funding allocation indicates a strategic alignment with global scientific endeavors. Significance: researchers must navigate a complex landscape of eligibility criteria and funding cycles to secure support for their projects. Understanding these nuances can be critical for maximizing the potential of available resources. Moreover, the emphasis on collaboration with international missions highlights Canada's commitment to being a significant player in global space exploration. 4. Interdisciplinary collaboration. The reports emphasize the need for interdisciplinary collaboration among astronomers, biologists, and educators. This collaborative approach is vital for addressing the multifaceted challenges associated with exoplanet research, such as understanding planetary atmospheres, potential biosignatures, and the implications for life beyond Earth. Significance: this interdisciplinary perspective encourages researchers to think beyond traditional boundaries and fosters innovative solutions to complex scientific questions. Such collaboration can lead to breakthroughs that may not be possible within siloed disciplines. 5. Technological advancements and infrastructure development. The anticipated increase in funding is expected to drive advancements in technology and infrastructure necessary for exoplanet research. Projects like the Pandora Mission and the Nancy Grace Roman Telescope represent significant investments in the technological capabilities needed to explore exoplanets and their atmospheres. Significance: the development of cutting-edge technologies can have ripple effects across various sectors, including telecommunications, materials science, and data analytics. Moreover, by investing in infrastructure, the CSA is laying the groundwork for sustained scientific inquiry and discovery. 6. Long-term research and sustainability. The timeline outlined in the reports indicates a sustained commitment to exoplanet research through 2027 and beyond. This long-term focus is essential for yielding meaningful results and ensuring that the investment in research translates into tangible scientific outcomes. Significance: long-term research initiatives allow for the accumulation of knowledge and data over time, leading to a deeper understanding of exoplanets and their potential for habitability. It also encourages researchers to think about the sustainability of their projects and the impact of their findings on society. 7. Global implications for astrobiology and life detection. As the search for exoplanets intensifies, so does the quest for understanding the potential for life beyond Earth. The funding increase signifies a recognition of the importance of astrobiology, which seeks to answer fundamental questions about life's existence elsewhere in the universe. Significance: discovering signs of life or habitable conditions on distant planets would have profound implications for humanity's understanding of its place in the cosmos. This funding can lead to discoveries that reshape our scientific and philosophical perspectives on life and existence. Conclusion: the anticipated increase in funding for exoplanet research across various sectors represents not merely an infusion of resources but a transformational moment for scientific inquiry and public engagement. The significance of this funding increase extends beyond immediate research outcomes. It encompasses educational advancements, interdisciplinary collaboration, technological innovation, and the potential for groundbreaking discoveries related to life beyond Earth. These aspects, while potentially overlooked, are crucial for understanding the broader implications of this funding surge and its potential to shape the future of science and society. The anticipated 50% increase in funding for exoplanet research by 2027 across the sectors of astronomy, astrobiology, space exploration, and education provides a multifaceted opportunity for growth and discovery in the scientific community. Here are 4 of the most valuable points for in-depth analysis and discussion. 1. Research expansion and technological innovation. The proposed funding increase is expected to significantly expand the scope and scale of exoplanet research. Currently, exoplanet studies contribute to approximately 3 to 4% of refereed astronomy articles and 15 to 20% of space missions. Projects such as the Pandora Mission and the Nancy Grace Roman Telescope are at the forefront, potentially discovering and characterizing a vast number of new exoplanets. The integration of advanced technologies such as the use of cutting-edge telescopes and data analysis methodologies will facilitate a deeper understanding of planetary systems and their atmospheres. This expansion is critical not only for scientific knowledge but also for fostering technological advancements that could have broader applications in various fields. 2. Public engagement and citizen science. The importance of public engagement in science is underscored by the anticipated funding increase. Citizen science initiatives have shown a remarkable ability to enhance public interest and participation in scientific endeavors, especially in the search for extraterrestrial life. Programs that involve amateur astronomers and the general public in exoplanet discovery and data collection can drive awareness and support for scientific research. The positive media portrayal of exoplanet discoveries has also contributed to a shift in public perception, making the idea of extraterrestrial life more palatable and exciting. This shift not only aids in funding acquisition but also inspires future generations to pursue careers in STEM fields. 3. Interdisciplinary collaboration and global participation. The enhanced funding will encourage interdisciplinary collaboration across various scientific domains including astronomy, astrobiology, and education. By supporting projects that integrate different scientific perspectives, researchers can develop a more comprehensive understanding of exoplanets and their potential for hosting life. The Canadian Space Agency's efforts to make Canadian researchers integral to international space missions exemplify the importance of global collaboration in advancing space science. This cooperative approach not only enhances the scientific output but also positions Canada as a key player in the international space research community, thereby attracting further investment and talent. 4. Educational impact and workforce development. The anticipated increase in funding for exoplanet research is likely to have significant implications for education and workforce development. By supporting initiatives that promote STEM education at various levels, funding can inspire students to engage in scientific research and exploration. Additionally, the creation of new research opportunities will cultivate a generation of scientists with expertise in space science and technology. This not only benefits the scientific community but also contributes to the broader economy by developing a highly skilled workforce capable of addressing future challenges in space exploration and related fields. Conclusion. The projected 50% increase in exoplanet research funding represents a transformative opportunity for scientific exploration, public engagement, interdisciplinary collaboration, and educational advancement. As the funding landscape shifts, the implications for our understanding of the universe and the potential for discovering extraterrestrial life will become increasingly tangible. This multifaceted approach not only enhances scientific knowledge but also fosters a culture of innovation and inquiry that can benefit society as a whole. Here are 3 famous historical cases that illustrate significant funding increases and shifts in scientific priorities similar to the anticipated increase in funding for exoplanet research. 1. The Apollo Program 1961 to 1972. The Apollo program was a pivotal initiative in the United States space exploration history, particularly in the 1960s and 1970s. Following President John F. Kennedy's 1961 announcement to land a man on the moon by the end of the decade, NASA experienced an unprecedented surge in funding. The program's budget grew from about $9 billion in 1965 to more than $25 billion by 1973, equivalent to roughly $150 billion today when adjusted for inflation. This funding enabled the Apollo missions, which not only achieved the historic moon landing in 1969 but also advanced technology in various fields including materials science, telecommunications, and computer technology. The Apollo program's impact extended beyond space exploration, significantly shaping public interest in science and technology, stimulating STEM education and fostering international cooperation in scientific endeavors. 2. The Human Genome Project 1990 to 2003. Launched in 1990, the Human Genome Project (HGP) aimed to map all the genes in the human genome. The project saw a substantial increase in funding over its duration, with the U.S. government investing approximately $3 billion. The initial funding was relatively modest, but as the project gained momentum, it attracted more substantial financial support from various sectors, including private companies and international collaborations. The HGP's completion in 2003 not only provided a complete reference sequence of the human genome but also revolutionized fields such as genetics, biotechnology, and medicine. It fostered new technologies and methods for genetic research and enhanced public understanding of genetics, leading to advancements in personalized medicine and genetic therapies. 3. The Large Hadron Collider LHC Project 2000-present. The Large Hadron Collider, located at CERN, the European Organization for Nuclear Research, is one of the most ambitious scientific projects ever undertaken. Construction began in the late 1990s, with the LHC officially inaugurated in 2008. The project, which cost about €7.5 billion over $10 billion, was funded by contributions from CERN's member states and other participating countries. The LHC was designed to explore fundamental questions about the universe, including the existence of the Higgs boson, which was confirmed in 2012. The LHC has not only deepened our understanding of particle physics but has also contributed to advancements in technology, including improvements in data processing and computing. The project's funding and international collaboration have significantly raised public interest in physics and the sciences, showcasing the importance of fundamental research in understanding the universe. These cases reflect how increased funding and strategic prioritization can lead to significant advancements in scientific understanding and public engagement, similar to the anticipated funding increase for exoplanet research. The anticipated 50% increase in funding for exoplanet research across the sectors of astronomy, astrobiology, space exploration, and education by 2027 represents a transformative moment in the scientific landscape. This surge in investment is expected to greatly enhance our understanding of the universe, foster public engagement, and stimulate technological innovation. Below are predictions on how this funding increase will impact various aspects of exoplanet research and related fields. 1. Enhanced research capabilities. With a significant increase in funding, research capabilities in exoplanet studies will expand dramatically. We expect to see advanced instruments and technologies. New telescopes and instruments such as the Nancy Grace Roman Telescope and the Pandora Mission will come online, enabling the discovery and characterization of thousands of exoplanets. These instruments will be critical for studying planetary atmospheres and identifying potential biosignatures. Collaborative international projects. Increased funding will facilitate greater collaboration between countries and institutions, leading to international missions aimed at exoplanet detection and analysis. This collaborative spirit will enhance data sharing and foster a more integrated global approach to space exploration. 2. Growth in educational programs. The infusion of funds into the educational sector will likely lead to an increase in STEM education initiatives. Universities and educational institutions will expand programs focused on astronomy, astrophysics, and astrobiology, attracting a new generation of students. This includes outreach programs that engage K-12 students through citizen science projects, fostering interest in STEM fields. Training and development. With more funding, there will be more opportunities for training graduate students and early career researchers in cutting-edge research methodologies and technologies related to exoplanet science. 3. Increased public engagement and citizen science. Public interest in exoplanets has surged in recent years, and increased funding will enhance this engagement through citizen science programs. With platforms like Zooniverse, the public will have more opportunities to contribute to exoplanet research, such as classifying data from telescopes or participating in observational campaigns. This democratization of science will not only raise awareness but also yield valuable scientific insights. Media and outreach. Funding will support media initiatives aimed at educating the public about exoplanet discoveries, potentially increasing support for scientific endeavors and funding initiatives. 4. Breakthroughs in astrobiology. The funding boost will likely catalyze significant advancements in astrobiology, including research on habitability. With more resources allocated to studying exoplanets' atmospheres and surface conditions, researchers will gain better insights into which planets may support life. This will include identifying biosignatures and understanding the environmental conditions necessary for life. Interdisciplinary research. The convergence of astrobiology with fields such as geology, chemistry, and atmospheric sciences will be supported, leading to more holistic research approaches. 5. Technological innovations. The demand for advanced technologies in space exploration will spur innovation in data analysis tools. As datasets from telescopes become larger and more complex, there will be a need for sophisticated data analysis tools utilizing machine learning and artificial intelligence to process and interpret findings effectively. Spacecraft and instruments. Increased funding will likely result in the development of new spacecraft and instruments that can operate in extreme environments, enhancing our ability to explore distant worlds. 6. Economic impact. The anticipated funding increase will not only benefit scientific research but also have broader economic implications. Job creation. Expanding research programs will create jobs in academia and industry, particularly in technology development, engineering, and data analysis. Industry growth. The increased focus on space exploration may stimulate the growth of private space companies and related industries, leading to innovations that benefit other sectors such as telecommunications and materials science. 7. Long-term vision for space exploration. Finally, the increased funding for exoplanet research will align with broader goals for space exploration. Preparation for future missions. The knowledge gained from studying exoplanets will inform future manned missions to Mars and beyond, as understanding planetary environments becomes crucial for human exploration. Global collaboration in space policy. As nations work collaboratively on exoplanet research, this may foster stronger international agreements and policies governing space exploration, potentially leading to a unified approach to challenges such as space debris management and the ethical implications of extraterrestrial life discovery. Conclusion. The anticipated increase in funding for exoplanet research will have far-reaching implications across multiple sectors, driving innovation, enhancing scientific understanding, and fostering public engagement. This funding surge will not only deepen our knowledge of exoplanets but also set the stage for future explorations that could redefine humanity's place in the universe. As we approach 2027, the scientific community and society at large will likely witness a golden age of discovery in the quest to understand our cosmic neighbors.